Okay, so here's another example of what we're going to be using is probably the segment addition postulate. Our diagram has a bunch of segments in it. So again, what I would do is pause the video and make sure you write down your given. Notice there are 3 pieces of given in this particular proof. And don't forget your proof and then your columns for your statements and reasons. So again, I would pause this and then copy that down and then restart. So like I had mentioned previously, if I have 3 pieces of given, I do not want to see all 3 pieces tucked into the first statement. I want to use one for as far as I can go and then introduce the next one. So I have C is the midpoint of AE. The reason is given. Now this is something that we worked on in class. What do I know if C is the midpoint of AE? Well, I know then that AC is congruent to CE. And I'm not really, the word is technically congruent. If you have an equal sign tucked in there, I am not going to count off for that. Okay, so I might have some extra steps in there, but I'm not going to be that nitpicky. So this is going to be the definition of midpoint. Now, I also talked about in class, if you have keywords, you're probably going to somewhere in your proof have definition of midpoint. If it said C was the bisector, then I would have the definition of bisector, for example. So because I know that AC is congruent to CE, I am going to mark that on my diagram. So I have exhausted that piece of given. So that means I'm going to introduce my next piece of given. C is the midpoint of BD. So if C is the midpoint of BD, then I also know that those 2 pieces are congruent. So I can say, actually this is going to be a given. So I know then that CD, or I'm going to look at this because right now I just said DC or CD or DC. I'm going to look in my proof up here. If it says CD somewhere in my given or my proof, then I do not want to use DC because that's just going to confuse the crap out of me. So if I have CD, I want to make sure that I'm consistent through my proof and still use CD. So I know that CD is congruent to BC. Now notice I don't have that anywhere, so I can do whatever. BC by, again, the definition of midpoint. So I've exhausted that piece of given. So I have one more piece of given left, and that is the fact that AE equals BD. And that would be given. So I know that AE, mark this in my diagram, AE is congruent to BD. So again, my diagram's getting a little bit busy right now. Okay, so I'm kind of stuck. So I'm going to look at what do I have? Well, I have segments. And 99% of the time, if I am using segments, I'm probably going to have to use the segment addition postulate. Well, because I'm at a standstill, I am going to use the segment addition postulate, for sure. So I know that AC plus CE equals AE. So AC plus CE equals AE. And I can say that because of the segment addition postulate. Okay, so that covers this segment. I have my other segment. And again, I want to be consistent. So CD plus, I used BC earlier, equals BD. Again, segment addition postulate. Okay, so what we are doing now is, let's look at the proof. The proof says that AC equals CD. So I'm trying to prove that AC equals CD. So what I'm doing is I'm taking this segment, or a piece of this segment, and a piece of this segment, and again, I'm trying to merge them together. So if I'm merging them together, I'm probably going to have to use substitution somewhere. So let's look at what we have here. We know that AE is congruent to BD. Look what we have here. Here's AE and here's BD. And I know that these are equal. So just like the last proof, I can put this piece into here and this piece into there. So I know that AC plus CE equals, where are we at? CD plus BC. Okay. And I can do that by substitution. And for substitution, I like to put what segments I used. So I took the idea of 6 and 7 and put it into 5. So I used 5, 6, and 7 to create this new statement. Okay, so I'm looking at what I have. I'm trying to get AC and CD all by itself. AC and CD. So I need to somehow make a connection between CE and BC. Okay, so I see that BC, CE, and CD is congruent to BC. And if that is true, BC So CD is congruent to BC. CD is congruent to BC. That means those would be the same. I may have to try this again. Let's see here. Okay, I guess I'm going to try to figure out why we were given this. So AC is congruent to CE. So that means in the next step that I can change AC into, or excuse me, CE into AC, because it says up here that they are congruent. So anywhere I see a CE, I can put it in AC. Anywhere I see a CD, I can put a BC or vice versa. And so that is by substitution. This might be a little bit difficult. So I use the idea of 2 and 4 and put it into 8. So I use 2, 4, and 8. Let's see what happens here. So AC plus AC is 2 AC. CD plus CD equals 2 CD. And that would be combining like terms. And it's combined like terms because I'm just combining them on the same side. Now I'm going to divide both sides by 2. And I get AC equals CD. So that is the division property of equality. I may have to try that one again and see if there's an easier way of doing that. Okay, so that's part of a proof, is kind of the trial and error piece, and there's not always a cut and dry one way of doing it. So I had a really hard time seeing that one. So I'm going to put the 3 dots there because my proof does match my last statement, so I am done. But you might see another video of this and try it again. See how that goes.